Welcome to this session on embracing deep learning with the ArcGIS API for Python. My name's Damien Robinson. I'm a senior managed cloud services consultant within Esri UK. I specialise in Python, PowerShell, cloud automation and innovation, and I've been working for Esri for over 6 years, sitting on our software engineering group and developing out our managed services capability.
My name's David. I've been on the Esri UK graduate scheme. I've been with Esri UK for 2 years. We get a bit of a basis in all the different parts of the tech, but I have a particular focus on Python. Right back to you, Damien.
Cheers, thanks, David. Okay, so in this session we'll be providing some fundamental scene setting around deep learning, introducing deep learning as a concept, where it sits within the ArcGIS platform. We'll then walk through a deep learning demo, and then we'll be followed by information on the ArcGIS API for Python, how to get started, some licensing and some key resources and documentation. So there'll be QR codes on screen at points throughout this session. These codes will have a brief description and will link out to some useful documentation. So feel free to scan these at your leisure. So to start off, we have to ask a fundamental question: what is deep learning? As you'll see on screen, it's a branch of machine learning, which itself is a branch of artificial intelligence. Artificial intelligence means mimicking the intelligence or behavioural patterns of humans. In a practical sense, this means creating algorithms to classify, analyse, and draw predictions from data. Machine learning is a branch of artificial intelligence in which structured data is processed with an algorithm to solve a problem. So machine learning tools have been a core component of spatial analysis in GIS for decades. You've been able to use machine learning in ArcGIS to perform image classification, enrich data with clustering, and model spatial relationships. Deep learning is a subset of machine learning that utilises several layers of algorithms in the form of neural networks. So neural networks try to replicate the human brain's approach to analysing data. They can identify, classify, and analyse diverse data and deal with many variables. Input data is analysed through different layers of the network, with each layer defining specific features and patterns in the data. So for example, if you want to identify buildings and roads in an image, a deep learning model can be trained with different images of buildings and roads, then processes these images through the layers within the neural network, finds the key identifiers required to classify that as a building or a road. Computer vision, or the ability of computers to gain understanding from digital images or videos, is an area that's been shifting from traditional machine learning algorithms to deep learning methods. So there's many computer vision tasks can be accomplished with deep learning neural networks. Esri's developed a bunch of tools that allow you to perform many tasks. On screen are some examples that I'll briefly run through and suggest potential use cases of the approach. So image classification involves assigning a label or class to a digital image. So imagine you have a large collection of orthoimagery and you only want to identify the tiles that contain buildings. So you can classify each image as either containing a building or not containing a building. This can be really useful as a data prep step because it reduces unnecessary analysis and computation against tiles with no buildings present. In this example, the whole image would be labelled as containing a building. Object detection is the process of locating features within a digital image/video. In this example, the neural network has found wind turbines within the image. Sometimes with object detection models, a precision value can be presented for the object, and this usually has a percentage. Ironically, seeing as we're talking about GIS and at a GIS conference, this precision value is called a MAP, or mean average precision. Semantic segmentation occurs when each pixel in an image is classified as belonging to a class. In the remote sensing world, the classic example of semantic segmentation would be automated land cover classifications from aerial imagery. Instance segmentation is a more precise object detection method in which the boundary of each object instance is drawn and extracted. In this example, mangrove forest land cover has been identified, classified, bounded, and extracted from aerial imagery. Image translation is the task of translating an image from one possible representation or style to another. In this example, the image on the left shows an original low-resolution image, and the image on the right shows the result of a super-resolution model. So this can be an extremely useful tool for improving the quality of imagery, which can improve the accuracy of the model. Change detection deep learning tasks can detect changes in features of interest between two dates and generate a logical map of change. In this example, the image on the left shows a housing development 5 years previous. The middle image shows the development today, and the image on the right shows the logical change map where new homes are classified in white. So that's just a quick summary of the tasks we utilise within the ArcGIS platform. So I've put up this slide just to demonstrate the proliferation of deep learning within the platform. It's everywhere, and as such can be confusing what offerings are available to you. I'll demystify this shortly, but first we need to understand the deep learning models available to us. So let's consider pre-trained versus bespoke models. For any Simpsons fans out there, Season 3, Episode 4, where Homer's brother Herb allows him to design a car. We can think of pre-trained versus bespoke models in those terms, so please bear with me on this one. If we think of the classic Simpsons car, it's a standard American saloon car. Of course, there's aspects of this car that can be changed. You can change the wheels, the body kit, the lighting, the seating, etc. This is similar to a pre-trained deep learning model. It can be extended beyond what is provided as standard. So now think to the car that Homer designed. For any Simpsons superfans out there, you know what's going to appear on screen right now. So this may be an exaggerated example of a bespoke model in that the Homer completely bankrupted his brother's business, but it highlights that bespoke models really are whatever you want them to be. And if you know what you're doing, there's some really cool, exciting stuff that can be achieved. If you don't, you could end up with the Homer. With ArcGIS pre-trained models, you do not need to invest the time and effort into training a deep learning model. They've been trained on data from a variety of geographies, and they work well across those geographies. So as new imagery becomes available, you can extract features and produce layers for mapping, visualization, and analysis. The pre-trained models are available on the ArcGIS Living Atlas to anyone with an ArcGIS account. Pre-trained models are the easiest and most accessible route into the deep learning models on the platform. So some of the most utilised models are the land cover classification tools, specifically for Sentinel and Landsat imagery. So I've rambled on long enough. It's time to get to the part we've all been waiting for, the demo. Away you go, David.
Thank you, Damien. So today we're going to show how we can do an object detection workflow. And we're going to keep it nice and simple. I want to highlight you don't need to be a data scientist and you don't need to be a Python coder to do this. Up on the screen, we have ArcGIS Pro. And with this comes a wide range of deep learning tools that we can start utilizing. We're going to incorporate this into a Python notebook, and we're going to try and keep it nice and simple. So up on the map view, you can see that we have some satellite imagery, and this is off a city called Newry. If you can't tell by the accent, Damien and I are from Northern Ireland, so Newry, of course, is a shopping city in Northern Ireland. In the center, within the green box, we have some drone imagery, and if we zoom in, we can see we have some fantastic detail within this. Each of these pixels on the image denotes about 3 centimeters on the ground. Now, we sourced this from Open Aerial Map, and this is just an open source data library for drone imagery. If you're looking to use any of the workflows today, I definitely recommend just giving a go with some of this imagery. If you find yourself with a use case where you maybe have satellite imagery and it's just maybe not between the 5 to 50 centimeter resolution you're aiming for, you definitely want to look at maybe image upscaling, as Damien touched upon. Now, in today's demo, we've been tasked with counting cars in a local shopping centre. And from this, we want to do some analysis in calculating the approximate footfall based on the total number of cars, as well as maybe the estimate revenue people may spend in these shops. Now, we could be old-fashioned about this, and we could start counting the cars in this image, but I'm quite lazy, and I really don't like doing that. So we're going to use deep learning to complete this. Now, traditionally, what we would need to do is we would need to train a deep learning model. And this would mean going into our geoprocessing toolbox here, and under Image Analyst, we have a deep learning tool set. As part of this, we would have to start drawing boxes around these cars to say to the model, look, here's an example of a car, and here's an example of a car in a different color. And usually you'd have to give a good number of samples, maybe about 100. However, again, that does take quite a bit of time to do. It does take some understanding to complete the workflow. So we're instead going to use a pre-trained model. Now, if we go to our ArcGIS Online content and then access the Living Atlas, this is open source data for anyone with an ArcGIS Online account. If you just type in DLLPK, the file extension for deep learning packages, you get access to these pre-trained models. And you can see we have some fantastic examples here from land cover classification, tree point classification, roads, even buildings. In today's use case, though, we're going to be counting cars, so we're going to use the car detection model. Now, I've already gone ahead and downloaded this and put it on my local hard drive. So we'll move on to our notebook. Now, anyone who's ever used a notebook before, this will look really familiar to you, but anyone who's completely new to it, don't worry, don't let the code scare you. Notebooks is just a really nice environment where we can start putting code into cells and start mixing in additional cells with text and documentation. If you're just looking to dip your toes into Python coding, I would definitely recommend looking up some of the sample notebooks and just tinkering with them. Find out what happens when you change certain variables. Now, for the first cell of our notebook, and it's always important for any notebook in ArcGIS Pro, is our system imports. And typically, you need to import your ArcGIS, you need to import your GIS, you need to import your system. Please always check the documentation for any tools you're using, because typically there'll be a section in Python and it will show you what imports you need to put into your code. So once you've done that, you can run the cell. And the next, we want to log into ArcGIS Online, and we can do this with the following code. This will just simply log us in with our currently logged in credentials in ArcGIS Pro. Next, we're just going to keep it nice and simple. We're going to run literally one geoprocessing tool to finish this workflow. We're going to run a tool called Detect Objects using deep learning. In this next cell, we're basically setting our variables for this tool. So there's quite a bit here, but we'll keep it nice and simple. To start, we have our in raster. This is the image we want to do our detection against. Next, we have our out detected objects. So this is going to be a feature class showing where cars have been detected. It'll be drawing polygon features around these. Up next, we have the deep learning model, which we downloaded from the Living Atlas. This is the model that's going to be used. Next, we have our model arguments, and as with all geoprocessing tools, sometimes we might not understand things. As always, check the documentation. But the most important things set against this is firstly the threshold. So this is the confidence value for the model. We have a value of 0.5, so this means the model will only say something is a car if it's more than 50% confident that it is correct. Next, we have the batch size. So this is just how much of the image will be processed at once. If you're setting your environment, your processor to a GPU, you want to try and get this as high as you possibly can. But if you hit errors with memory, drop the batch size down. Finally, the tile size is something I would definitely tinker with if you're finding it's the model showing up features that are really small, not exactly what you're looking to detect. And the next, we have the M&S setting. So this stands for non-maximum suppression. This means if we have it enabled, the model will be prevented from detecting the same object twice. Now with that all set, we can run that cell to set our variables, and then we run the detect objects using deep learning tool. Now I'll admit some of the results weren't the best when I ran this. We got all the cars counted, but we did find that there were some areas where it was detecting things that just weren't cars. Luckily, it's nice and simple to fix this. What we've done the next cell is to say, I want to select all the features that are underneath, lower than 15 meters squared. I just took an average of the cars that were detected and found they were about 20 meters squared. So we're just selecting anything that's beneath that, and then we're simply deleting it. So if we switch back to our map view, we can see an earlier output that we created with the notebook. And here we can see we have these bounding boxes around the cars that have been detected. It's much nicer just to run that. I don't want to be counting these cars every time I look at an image. You can see there's some fantastic detection here. You see this example here of this car. It's half obscured. It is black, so it blends in the tarmac, and yet the model picks it up. Okay, sometimes you might get something like an AC unit that's been detected. You might need to delete it. Deep learning is not going to be 100% perfect, but it will get you 99% of the way there. And with enough training, you might actually get it 100%. So now that we've got a count of the cars, we just want to do some analysis with the footfall and the potential revenue. And for this, we're going to do a dashboard. Going into our notebook again, we're simply just, I've uploaded a web map to my ArcGIS Online portal, and we're simply just searching for this, as well as getting the layer from this. Once we get these items, we can start interacting with them in the notebook environment. In this case, what we're going to do is build a dashboard, so we need to put in some imports from the ArcGIS.apps.dashboard modules. In this case, I'm only interested in adding a header and a few indicators, so we import those. The add row and add column are just for the formatting of it, so where the elements will be positioned in the dashboard. Next, these few cells here are going to show the individual elements. So we have this one here for showing a web map, and then we have 3 cells for the different indicators. One for the total car count, one that's going to provide one on total footfall, and then one on the total revenue local shops might make. We next add a header just to add some text to the top of the dashboard. And then we set the dashboard up by configuring the layout in this following cell. Once we've done this, we simply just save it, and we have it published to ArcGIS Online. If we switch over to this, we can see the example of this. We have a count of the cars, as well as the projected footfall and the rough projected revenue based on the total number of cars. Now, we could do this over time. We could say, right, we'll have new drone imagery every Saturday. Let's just schedule the notebook and have a cup of tea and let the ArcGIS Pro and notebooks do all the work for us. So that concludes our demo. I'm going to hand this right back to Damien.
Great, thanks very much for that demo, David. That was brilliant. So hopefully it's given you some idea of the art of the possible when it comes to deep learning, the immense value and insight it can bring. I want to focus now on the ArcGIS API for Python. So the ArcGIS API for Python is a powerful Python library for mapping, spatial analysis, data science, geospatial AI, and automation. Although not within scope for this session, there's a wealth of information of getting started with the ArcGIS API for Python on developers.arcgis.com. The ArcGIS.learn module is a group of deep learning functions that enable GIS analysts and geospatial data scientists to easily adopt and apply deep learning. It empowers users to train state-of-the-art deep learning models with a simple, intuitive API. The ArcGIS API for Python integrates seamlessly with the ArcGIS platform by consuming exported training samples directly, and the models that it creates can be used directly for inferencing in ArcGIS Pro and Image Server. So you can see the low-level capabilities of the API in action within the sample notebooks provided on developers.arcgis.com. There are many excellent notebooks that contain real-world examples of the various computer vision tasks we talked through earlier. So for example, there's a sample notebook for increasing image resolution using the super resolution model. ArcGIS.learn provides super resolution model for increasing image resolution, and this is based on a pre-trained convolutional neural network called ResNet. This is just the tip of the iceberg with the API. There's a mass of models within ArcGIS.learn that can be utilized to complete the computer vision tasks we discussed earlier. So how do you get started? If you have access to an ArcGIS notebook server federated with your ArcGIS Enterprise deployment or ArcGIS Online, you'll have access to some deep learning sample notebooks directly within the system. There are 3 deep learning specific notebooks currently available. The El Nino sample notebook is the only one available in online. So the El Nino sample will probably be the initial entry point for most. And as it's available in online, it does actually consume credits. So there's around 40 credits spent whenever you run the El Nino sample. In terms of training resources, learn.arcgis.com provides a hub of online lessons with specific focus on real-world problems. There are multiple deep learning lessons that can be accessed through learn.arcgis.com, each giving an estimate on how long it should take. There's some great lessons on assessing palm tree health, classifying mangrove land cover, and classifying power lines, plus several others, so please be sure to check these out. So now we know how to get started, we need to understand what licenses we require. So to simplify things, I'll focus on the licensing requirements for pre-trained models. So to summarize generally, ArcGIS Online will require ArcGIS Image for ArcGIS Online to run pre-trained models. ArcGIS Pro requires the ArcGIS Image Analyst extension to extract image features, and to extract point cloud features, you'll need the 3D Analyst extension. ArcGIS Enterprise requires an ArcGIS Image Server to process models. So underlying the platform, we have the developer technologies for interacting with deep learning workflows. The ArcGIS API for Python allows access to every step of the deep learning workflow in a programmatic way and is seamlessly integrated with other components of the platform. We also have the notebooks, and they provide one-click access to pre-configured notebooks, Jupyter notebooks, along with the necessary deep learning libraries already installed and the ArcGIS API for Python. So hopefully this quick run-through on deep learning has demystified the topic somewhat for you and given you enough information to get started. It's a vast area of the platform, so it's hard to cover everything in a short space of time. I've pulled together some key documentation in the deep learning space that hasn't already been referenced via QR code, so these can be scanned now. Both of us will be on the developer stand for Q&A immediately after this session, should you have any follow-up questions. Thanks for your time today, and I hope you enjoy the rest of the conference.